Okay, question 22, you have to make use of your resistivity formula, and you need to use a bit of algebra. So for those who are weaker in maths, you may face a little bit of difficulty. So let's go through it step by step. Okay, so at the beginning, I first write down the resistivity equation for my y-axis. So for my y-axis, I know that my Rx is 10, and I will have all these unknown here, L and A. I just put it as an algebra representation. Then after that, I write another equation for the resistance of Y. Oh, it's not a resistance of Y, it's the resistance of the other piece of wire. Okay, because it is of the same material as X, my resistivity, I use the same symbol. Okay, rho. Then I know that my length in the other piece of wire is twice the original length. So for the length, I use the representation of 2L. Okay, then for my area, my cross-sectional area, if I expand this area out, it will be pi r squared, right? So down here, if I expand it out, let me draw it out. Okay, so down here it will be pi r squared. So if I expand this out, from the question I know that my radius is actually twice. So that's why from here I would have 2r, and I have to square it with the bracket. Can? So this is my first statement, my first expression. Then after that, I would want to try to simplify it. So on the left hand side, I'm not doing anything because I can't do anything anyway. So I'm focusing on only the right hand side of this equation. So the 2L, I can't do anything, but I open up this bracket. So 2R bracket square, it will be 4R squared pi. Right? So once I have that, this R square pi, and if you look here, pi r square and this pi r square is actually equals to A. So that's why this pi r square, I can change it to A. Okay, so once I know that, I see that, oh, then this pi LA and this this rho LA and this rho LA actually can be simplified to Rx, right? So I put this rho LA, I put it into Rx, my original resistance. And this 2 over 4, I can simplify into half. Then after that, I realize that, oh, I know the value of Rx. Rx is just 10. So half times 10 will give me 5. Can? Okay. Okay, question 3. Question 3, you need to know that when components like this are connected in series, the voltage is going to be shared. And the sharing is dependent on the resistance of these two components. Now, a lot of you are being confused by this additional wire here. So what is additional wire here? You can just treat it as like a voltmeter. The voltmeter, if you recall, if you have any circuit and you have a component here, you have a circuit here, your voltmeter also have an arm that goes this way. So just treat this thing as a connection to, let's say, a voltmeter. Okay, just treat it that way. It's not going to affect how your current is flowing. So some of you are telling me that, oh, so the current will flow from here, then after that it will split. Okay, it doesn't split. Okay, it doesn't split. Just treat that this is like a voltmeter being connected to it. Okay, so let me recap. These two things connected in series, and between them you have a power supply of 60 volt. So just treat this as invisible. Okay, so first let us look at the situation when it is very bright. So when it is very bright, the resistance ratio between the LDR and the fixed resistor will be 100 ohm is to 500 ohm. So I know that the ratio of resistance is 1:5 when it is bright. Okay, so if you have, let me find an eraser. So down here, if you have 60 volt, you are going to share it in 6 parts because the ratio is 1:5, right? So you're going to go into 6 parts, and the potential difference for the LDR will take up 1 out of the 6 parts. So once you do that, you know that, okay, the potential difference across the LDR will be just 10 volt. So meaning that when it is bright, if you start off at 60 volt, when it is bright, the LDR is going to take up 10 volt. So after 60 volt take up 10 volt, your Y will be left with 50 volt. Okay, so now I know that when it is bright, my Y will have a potential of 50 volt. Now when it is dark, the LDR resistance is going to increase to 1000 ohm. So now the resistance ratio between the LDR and the fixed resistor changed to 2:1. Okay, so my potential of 60 volt is now going to be divided into 3 parts, and out of these 3 parts, 2 parts of it will go to my LDR. So meaning that my LDR will take up the potential of 40 volt. So meaning that this 60 volt, when it goes across the LDR is going to use 40 volt. So meaning that Y is now being left with 20 volt. So from here you can see that when it is bright, Y is 50 volt. When it is dark, Y is 20 volt. So that's why your option A, a fall from 50 volt to 20 volt, is correct. Okay. Okay, let's continue with question 34. So this question is about your knowledge in terms of the power grid in Singapore. So for the neutral wire is where the electricity actually return to the power station, and your live wire is the one that is of a higher potential. So logically speaking, if your live wire is of a high potential, your neutral wire must be at the lower potential, and your live wire is at 240, so your neutral wire must be at 0 volt potential. So that's why you can rule out option C and option D. Now the thing about this question is that there's already a current flowing in the live wire. So when the current flows into the live wire, it will go through your circuit of your heater, and then it will return to the source through the neutral wire. So the current in the neutral wire must be 1 ampere. So your answer B. Okay, question 36. Question 36 is just a very simple and common question. So light pole repel each other. So if the field is going this way, means that you can imagine that there is a giant north magnet here and a giant south magnet here. So of course the north pole of this bar will be attracted to the south pole of this side. So definitely your bar is going to rotate 90-degree anti-clockwise. So your option C. Okay, for question 36, there is a very detailed drawing in your textbook showing you why the wire will get attracted or repel from each other. So please look through that if you are not really sure why they attract or repel each other. The rule is that if the wire is going in the same direction, it will attract, and if it is going opposite direction, it will repel. So clearly Q and R is going different directions, so they will repel each other this way. And if you look at P and Q, the current in them are flowing in the same direction, so they will attract. So with this, you can see that the option B is correct. Okay. Okay, question 37 is very interesting. So you have to make use of Faraday's law and Nernst's law. Okay, so let's see, let's go through all these 1, 2, 3, 4, 5 one by one. So when switch S is closed, coil 2 is stationary while coil 1 move upward. So what happens is that when switch S is closed, you will have a closed circuit, and because the coil 1 is moving nearer to because coil 1 is moving upward, it is going to experience a decrease of magnetic field line from coil 2. So according to Faraday's law, as long as the coil experiences any change in magnetic field strength, the coil will get an induced current. So your number 1 circuit is closed and it is experienced a change in magnetic field strength, and so definitely there will be an induced current flowing in coil 1. So number 1 is correct. Okay, number 2 again, switch S is closed, so you have a closed circuit. Coil 2 is moving away and coil 1 is stationary this time. Again, with this arrangement, coil 1 will experience a change in magnetic field strength. So definitely there will be an induced current. Number 3, both coils are stationary. So now that both coils are stationary, even when coil 1 is being switched on or off, because in coil 1 there is no power source, there's no battery in it. Whether or not you switch on and off your switch S, it will not create any change in magnetic field strength. The magnetic field strength comes from this battery right here in coil 2. So whether or not you switch on and off in coil 1, there will be no induced current. So 3 is wrong. Point 4, switch S is closed, variable resistor R is increased rapidly. So once you close the circuit in coil 1, now what you are tampering with is this resistor here. So by changing this resistor, basically what you are changing is the current flowing in coil 2. And if you change the strength of current flowing in coil 2, you are actually changing the magnetic field strength caused by the current in coil 2. So from the point of view of coil 1 will experience this change of magnetic field strength in coil 2, and therefore there will be an induced current flowing in your coil 1. So point number 4 is valid. Now if you look at point 5, your switch S is closed, coil 2 is moving away while coil 1 is moving at the same rate and in the same direction as coil 2. So what this long sentence means is that let's say this finger is coil 1, this finger is coil 2. So when coil 2 move away, coil 1 is going to follow in the same direction at the same speed. So to coil 1, will there be a change in magnetic field strength? No, there will not be, because the relative distance between them is the same. Yeah, so no change in magnetic field strength, no induced current. So that's why 5 is also out. Okay? Okay, question 39 is your standard OCR question. You need to take care of the unit given here, and when you count the square, so let's say in this case I am to count the amplitude of the voltage, it will be 2 square, 2 division. So each division is 2 volt, so therefore I will have 4 volt. So A and C, B and D will be out. Then if I look at this wave, this is one complete oscillation, so the width of this wave will give you the wavelength directly. So the wavelength is 1, 2, 3, 4, 4 division, and each division is 2 milliseconds. So now I have 4 division, it will be 4 times 2. So now the period will be 4 division multiplied by 2 milliseconds, which is 0.002 seconds. 1, 2, 3, correct. So your period is 0.008 seconds. So your frequency is 1 over T. So once you put in the 0.008 here, you will get the answer 125 Hertz. Okay? Your question 50, you are actually given the turn ratio and you already know what is the primary voltage. So down here, just use your transformer equation. You should be able to get the answer directly. Okay? if you do not know what is the transformer equation, it will be the number of turn primary coil, number of turn secondary coil will be equal to the voltage of primary coil over voltage of secondary coil. Okay, and this MP over NS is already given here, the ratio, and you already know the 5 volt, you can put it here. So easy question.